So what we're going to do is look at a graph. Okay, so if this is the x-axis and the y-axis, what we're interested in is how far away a certain angle is from the x-axis, okay? So if I put in an angle here, I'm interested in how far away it is from the x-axis. So because we're starting here, we're going to call this 0 degrees. All right, I'm just going to move this down a little. So because this is 0 degrees, what does that make this? 90. And this is 180. And this is 270. Good. So if we're interested in how far away something is from the x-axis, this is an equivalent angle, right? Because it's this far away from the x-axis or the same on the other side. And the same is going to be true in the other direction. How far away is it from the x-axis and how far away on this side as well, all right? So in either direction, we're just going from the x-axis to wherever we need to go. Does that make sense? So these four angles are equivalent angles, but there is something else we need to take into consideration as well, and that is what ratio is being used. So we're going to use a little acronym that is CAST. Okay. Right, C-A-S-T, right? So CAST is just going to be helpful. C stands for cosine. A is for all. S is for sine. T is for tan, okay? So in this quadrant, all ratios are positive. So all the angles will be positive. In this quadrant, only sine is positive. Everything else is negative. In this quadrant, only tan is positive, everything else is negative. And obviously in this one, only cosine is positive, everything else is negative. So if we're asked to find equivalent angles, we need to think about which quadrants we're allowed to be in. So let me give you an example of that now. So if I said sine of 42 degrees, all right? So I'm going to change color. All right, so let's color code this. All right, so if I want sine of 42 degrees, what I'm going to do is say 42 is roughly here, right? So that's like 42. So I'm allowed to be in this quadrant because everything's positive in this quadrant. I'm also allowed to be in this quadrant because sine is positive in this quadrant. Now, remember, I only care about how far away I am from the x-axis. So I need to go 42 degrees in this direction. So isn't that just 180 minus 42? Make sense? So I'm 138 degrees. Are you with me? So these two, so 42 degrees and 138 degrees are equivalent angles. All right, let's do it again. All right, this time I'm going to say 22 degrees. All right, but this time I'm going to make it cosine. So cosine of 22. So what other quadrant am I allowed to be in? Well, just this one, right? I'm allowed to be in the all quadrant and in the cosine quadrant. So that means I need to go, let's pretend that that's 22 degrees as well. So isn't this just 360 minus 22? So I have to go all the way around, right? So 360 degrees is the whole way around and then minus this 22 bit. So if I've got 360 minus 22, what do I have? 338. So these are the two equivalent angles that have the same value. Let's do another one. All right, let's say that I called this 78 degrees, and this time I'm going to do tan. So tan of 78 degrees. So again, that's this angle from 0. So this is the other quadrant I'm allowed to be in. So I'm going to go again so if that is 78 degrees from the x-axis, I'm doing it again, 78 degrees from the x-axis. So essentially these are straight lines, right? Well, not entirely. Okay, 78 degrees. So isn't this 180 plus 78, right? I need to get another 78 degrees from there. So 180 plus 78 is 258. So that means my equivalent values are 78 and 258. Do you see what I'm doing? Yes? All right, let's keep looking at some other stuff. All right, so when you're asked for equivalent values, think about your cast circle. What we want to do is figure out what quadrants we're allowed to be in. Where are we positive? Which one do I need to go into? Am I going backwards from 360? This one's always positive. Am I going backwards from 180 or forwards from 180? So depending on what one you have, you should have one of each. Okay, let's look. Yeah, that'll do for that one. Okay, let's look more at the unit circle. So let's go back to our unit circle. I'm going to draw a circle. Okay, so if I draw a unit, oh gosh, we're going to pretend that that goes through the center. Okay, so what I'm saying, why am I green? All right, so if this is my unit circle, this is 1, this is 1, this is -1, this is -1. Unit circle is exactly what it sounds like, 1 unit in each direction, okay? If I am going to draw an angle here, there are ways that I can talk about the coordinates. So if I am talking about this point here, someone's very excited over there, the x coordinate, right? So this coordinate here, the x coordinate, we're going to call cosine of the angle. So if you think about what we're doing, SOHCAHTOA, right? Cosine is opposite over hypotenuse. So my opposite over my hypotenuse, that will give me this coordinate. But if I want the y coordinate, I'm taking the sine, where I say. Sorry. Yes. The cosine is the adjacent over the hypotenuse. Sorry. The cosine is the adjacent over the hypotenuse. So yeah, sorry, we're doing that. Of course, that makes more sense. What is wrong with my brain? The adjacent over the hypotenuse is giving us the x coordinate, and the y coordinate is going to be the sine of the angle, okay? So we can talk about this coordinate here as cosine of the angle and sine of the angle. That gives us this coordinate point on the unit circle, right? So that is a coordinate point. Now, the way we talk about tan of the angle is it's sine of the angle over cosine of the angle. Don't worry too much about this. I'll show you exactly what it means. All right, let's do some examples. It's going to get all small and weird, isn't it? Okay, let me show you what I mean. So if I'm talking about, actually, let's do some other examples. Okay, I'm going to zoom back in and save that. All right. All right, so what we're going to do is just quickly remind ourselves of some triangles. Okay, so if I have a triangle like this, okay, and this is going to be a what triangle? Isosceles triangle and a right angle triangle, right? So this is an isosceles right angle triangle. So what is this angle here? 45, right? It has to be. This is 90. These are equal. So this is 45, 45. So if I'm saying that this belongs in a unit circle, what length is this? 1, right? So that's 1, and so is this, because this would be where my circle goes, right? This would be the origin. This would be up to the circle, out to the circle. So I've got this information. Now, if I use, what do I use to find this length? Trigonometry, be more specific. Pythagoras, right? So we're going to use Pythagoras. So if I say 1 squared plus 1 squared equals h squared, 1 plus 1 equals h squared, 2 equals h squared. So what's h? Root 2. So this length is root 2. So when we talk about the unit circle, there are some things that we want to know off the top of our heads. This is one of them. If you have a 45-45 triangle, this is 1, 1, root 2. So you shouldn't have to do the calculations every time. We want to remember a couple of things. We want to remember a 45-45 triangle, and we want to remember a 30-60 triangle. So let's look at the 30-60 triangle. Okay, so Okay, so if this is 60 and this is 30, and again, that is going to be our right angle. Okay, if I am now talking about, you kind of want to think more about it like this, right? 60, 30. So if I had, this would be like, so that would be my line, and my line, like that's the y-axis, that's the x-axis. So that makes this 1. Okay, so this is like my, right? Those are my x and y axes. So this is 1, which makes, well, so what we want to do now, I didn't say this goes up to 1, right? So this bit does, this bit doesn't. Sorry? I'm telling you it is. So if we drew this on the unit circle, okay? So if we made this 1 on the unit circle and this was the edge of the circle, this, so this would not go through there. It would sort of be more like, whoops, more like that, right? I'm just going to delete that because it just makes it messy. But okay, so what we're going to do is, if we've got 1 and we've got all the angles, we can still use trig to find all our unknown sides, right? So let's find this one first. So if that's x, what am I going to use? If I've got this and I need this, what am I using? Cosine, or I could use sine or cosine. It doesn't matter because I've got all 3 angles. So it doesn't really matter which one I use as long as the hypotenuse is involved. So let's just use sine because we can. So sine of what? Sorry? Am I using 30 or 60? 30, right? Because 30 is opposite my 1. So sine of 30 is my opposite over my hypotenuse. So that means the hypotenuse is 1 over sine 30. That is going to give me 2. Isn't that amazing? And then if I do the same with this one, I can either use sine or cosine. It makes no difference. Let's do cosine this time. So cosine of what? 60? No. If I use 60, oh no, sorry. Yeah, no, that would be sine, wouldn't it? I need to do 30 again because I need the adjacent side. So that is something I don't know, and I do know that. So 2 cosine 30, which gives me root 3. So that makes this root 3. So 1, 2, root 3, 1, 1, root 2.